This is the last video for the quadratics module. In this video we're looking at the second half of Quad K, so we're looking at Quad K2. Now in this section we're looking at more application problems. Now you need to remember that the graphs of quadratic equations can be used to assist in solving practical problems, because in some situations where it's necessary to find a maximum or minimum value, you may need the vertex of the graph. So let's look at the first example. It says Sandcastle Shoe Company can sell up to 200 pairs of its beach thongs per day at a price P according to P equals 13 minus 0.05 Q, where Q is the quantity of thongs in pairs. It says find the number and the selling price of pairs of thongs needing to be produced to make a maximum company revenue, and the revenue is given by price times quantity. So let's start with that. So revenue equals price times quantity. Our price was the formula given to us, so 13 minus 0.05 Q, and the quantity is simply Q. So expand the bracket, 13Q minus 0.05 Q squared is our revenue. Now looking at that equation, if I rearrange it to put Q squared out the front, you can see that we have a negative coefficient in front of the Q squared, which means it's a sad parabola, so our maximum is going to be at the vertex. Now the vertex is going to be given by negative b over 2a, and b is 13, so negative 13 over 2 times negative 0.05. Plug that into your calculator and you get 130. So that's 130 pairs. Okay, now let's find out what P needs to be. P is 13 minus 0.05 Q, so 13 minus 0.05 times 130, which is $6.50. So therefore, the company needs to produce 130 pairs of thongs and sell them for $6.50 to maximise revenue. Okay, you always need to finish with a statement. Okay, so there's your answer there. Let's look at another example. An amusement park offers discounts for groups according to the following. For groups of 10 people, the admission price is $30 per person, while for larger groups, the admission price is reduced by 50 cents for each person in excess of 10. So if 11 people are in a group, the price is $29.50 per person. Find the group size that maximises park revenue. Well, we need to find numbers in a group, so let n be number of people, and because it changes when it's over 10, so we'll put over 10. Okay, so n is a number of people over 10, and that's in the group. From there, we know that the number in the group is going to be the initial 10 plus another n. Okay, and cost per person is going to be 30 minus 0.5 n, because for each person over 10 the admission price is reduced by 50 cents and the original admission price is $30. Okay, now revenue is cost times number of people, so that's going to be 30 minus 0.5 n, all multiplied by 10 plus n. Now if you expand that bracket out, 10 times 30 is 300, 30 times n is 30n, negative 0.5 n times 10 is negative 5n, negative 0.5 n times n is negative 0.5 n squared. Bring the n squared out the front, collect like terms, and there's our simplified formula for revenue. Okay, looking out the front, sorry, this should have been a squared term that I forgot to write. Looking at the front, we have a negative coefficient of the n squared term, so again we know it's a maximum point or a sad parabola, so so its maximum is occurring at the vertex. So to find its maximum, we're going to use n is minus b over 2a, which is going to be negative 25 over 2 lots of negative 0.5, which ends up 25. Now the question only asks to find the group size that maximises park revenue, so we don't need any more. So therefore, maximum revenue for a group of 25 people. Okay? Now another thing we use quadratics for is projectile motion. Projectile motion usually refers to the path followed by an object or a projectile. Projectile motion is a parabolic shape and hence defined using quadratic equations. Understanding the properties of quadratic graphs aids a solution of problems involving projectile motion. So in this question, a cannon is fired from the deck of a pirate ship with a speed of 15 metres per second. The height h in metres of the cannonball above C is given by h equals negative 5t squared plus 8t plus 4, where t is the time since firing. Sketch a graph of the path of the cannonball and use the graph to find the maximum height of the cannonball reaches, how long it takes for the cannonball to hit the ocean, and when the cannonball is 6 metres above the ocean. So we've got h equals negative 5t squared plus 8t plus 4. Out the front we have a negative coefficient of t squared, so it's going to be sad. Now let's find our h-intercept, and that is going to be when t is 0. Plugging t0 in there, I get h is 4, so that gives me 0, 4. Okay, now let's find the t-intercept. I'll just highlight that so we can find it. T-intercept is going to be when h is 0, so we get 0 is negative 5t squared plus 8t plus 4. Now I'm going to move it all over. I'm going to change the sign of everything so it's easier to work with. Now if you factorise that, you'll end up finding that t ends up being 2 or negative 2 over 3. Okay, so they're your x-intercepts. Sorry, I'm taking a bit of a shortcut. Now the vertex is going to be when t equals negative b over 2a, so that's going to be negative 8 over 2 lots of negative 5, so it's going to be 8 over 10, which is 4 over 5. Okay, so when t is that, h is going to be negative 5 times 4 over 5 all squared plus 8 lots of 4 over 5 plus 4. Okay, and that ends up being 7.2. So my vertex is at 4 over 5 or 0.8 and 7.2. Okay, now I'm just going to draw a quick sketch. You'd have to draw a more accurate graph than what I am, but we've got negative 2/3, which I'm going to put it there. 2. Okay, our intercept is at 0, 4, and our turning point, which should be in between these, we'll just put as there. Okay, so you've got a parabola looking something like that. You can see a more accurate graph in the textbook. Okay, so when we look at this now, the maximum height the cannonball reaches, well, the maximum height it reaches is 7.2. So it's 7.2, and we're dealing in metres per second, so it's metres. Okay, how long does it take for the cannonball to hit the ocean? Well, it's being released here at 2/3, but is it really? No, because our graph really can't be represented by this bit here. Okay, so really it's being released at this point here. Okay, and at 2 seconds it hits the ground again. Okay, so the cannonball hits the ocean after 2 seconds. When the cannonball is 6 metres above the ocean, well, for 6 metres above the ocean, this would be y is 6. Okay, so to find that, if we had an accurate graph, you could just read down off the graph. Okay, so if you've drawn an accurate graph, you'll find out that t is approximately 0.3 and 1.3 seconds. Okay, so that's a brief introduction to that problem. It's done in detail in the textbook. Your other option for doing the last part of the question would be to say, well, my height needs to be 6, so 6 is going to be negative 5t squared plus 8t plus 4, and then you would rearrange that to be 5t squared minus 8t plus 2 equals 0, and you would solve that to find accurate answers. Okay? What now? Practice time. Complete exercise quad K2. We are at the end of the module, so read the module summary, revise the module and complete the review exercise. Okay, so there's a module summary in the book and there's also a review exercise there. Then complete and submit the quad module test. Remember again, ask for help if you need it. So let's look at an example using projectile motion. This one says a cannon is fired from the deck of a pirate ship with a speed of 15 meters per second. The height h in meters of the cannonball above the sea is given by h equals negative 5t squared plus 8t plus 4, where t is the time since firing. Sketch a graph of the path of the cannonball and use the graph to find the maximum height the cannonball reaches, how long it takes for the cannonball to hit the ocean, and when the cannonball is 6 meters above the ocean. Okay, so if we need to sketch, we need to find some information. So we've got h is negative 5t squared plus 8t plus 4. In front of the t squared we have a negative 5, so we know it's going to be a sad parabola. Now let's find the t-intercept. T-intercept is when h is 0, so I've got 0 equals negative 5t squared plus 8t plus 4. I'm going to make that t squared term positive, so 5t squared minus 8t minus 4 equals 0. So I've just taken everything to the left. Now I'm just going to quickly use the cross method. I have 5t and t, so that makes 5t squared. Over here I need negative 4 and I need negative 8t. Okay, so if I pick 2 and 2, I've got 2t and 10t. If I make that negative 10t and 2t, I get my negative 8t. So this becomes 5t plus 2 and then t minus 2 equals 0. So from that, 5t plus 2 equals 0, 5t equals negative 2, t equals negative 2 over 5, which could also be written as negative 0.4. Okay, other side, t minus 2 equals 0, t equals 2. So I have my t-intercepts. To find my h-intercept is when t equals 0. If I plug 0 into here, I get 0 plus 0 equals 4. So h is 4, so that's 0, 4. Next one, I need to find my vertex. Now vertex is when t is going to be negative b over 2a. Negative b, well b in this case, looking up here, is 8. So I've got negative 8 over 2 lots of a, and a is negative 5, so 2 lots of negative 5. So that's 8 over 10, which is 4 over 5, which can also be written as 0.8. Okay, so when t equals 0.8, h is going to be negative 5 times 0.8 all squared plus 8 times 0.8 plus 4, and you end up getting h is 7.2. Sorry about running out of room. So 0.8, 7.2. Okay, now we need to graph it. On a new page, let's recap what we've got. I have a sad parabola, and my points that I found were 2, 0, and negative 0.40 for my x-intercepts, or in this case t-intercepts. My h-intercept was 0, 4, and my vertex was 0.8, 7.2. So let's put this on my graph. I've got 2, 0 is there, negative 0.4, so this is going up in 0.2s, so negative 0.4 is there, okay, then 0, 4, and then I've got 0.8, 2, 4, 6, 8, 0.8's there, 7.2, no, that's 7.5, so it's going to be about there, and then I join the dots. Now remember, these solutions are only as accurate as your graph, as I've said before. Okay, so this point here was 0.8, 7.2. Now let's answer the questions. The first one was the maximum height the cannonball reaches. Well, you can see that's 7.2, and we were dealing in meters, so it's 7.2 meters. On my graph I should actually have, instead of y, I should have h, which is in meters, and here I should have time, and it was in meters per second, so that's in seconds. Okay. How long it takes for the cannonball to hit the ocean? Well, I should take this opportunity to tell you that our graph doesn't really exist down here. Reason being, we can't have negative time. So just remember what the cannonball is actually doing is starting at this point and heading around. Okay, so just be wary of that. So you've actually got that part of the graph there. I should draw that a bit better. Okay. So how long does it take to hit the ocean? Well, it hits when it's here, and I don't have this part of my graph either. Okay. So I'm going to redraw this to make it a little bit neater for what we actually have. Okay. So what we technically have is this. Something looking like that. Okay. So how long it takes? It's 2 seconds. When the cannonball is 6 meters above the ocean, well, 6 meters is here, so we draw a line going across, and then we come down to our axes. Okay, 2.2, 0.4, so that's 0.4. This is 1.2. Okay, we're only using our graph, that's what the question said, so it's at 0.4 seconds and 1.2 seconds approximately. Okay, it'll depend on your graph. If you wanted to solve that accurately, what you would do is your equation was h equals negative 5t squared plus 8t plus 4, and you want h to be 6. So you go 6 is negative 5t squared plus 8t plus 4. Get everything on one side. Okay, and you would use your quadratic formula to solve it. Okay? What now? Okay, it's the last module, last exercise in the module. Complete exercise quad K2. Okay, read the module summary, revise the module, complete the review exercise. Then you need to complete and submit the quadratic module test. Remember again, ask for help if you need it.